In this example, we are going to be doing the limit as x approaches infinity of x squared times sine of 1 over 4x squared. So with any limit, my first thing to do is to just go ahead and plug in an infinity, see what happens. So x squared is going to be infinity. And then sine this is going to be 1 over something that's infinitely large, which is going to make this whole fraction infinitely small, which is essentially, this is approaching 0. So sine of 0 is 0. So you have one of these values that's getting infinitely large, one of these values that's getting infinitely small. We're trying to figure out which one overrides the other. I have no idea. But this is then turns into a L'Hopital's rule situation. So we have all these different kind of scenarios that if we have a 0 over 0, those are kind of your most common situations, infinity over infinity. But we have something like this, where we have a 0 times an infinity or infinity times a 0. So we can apply L'Hopital's rule. But L'Hopital's rule is you need to turn it into a fraction. And so we are going to turn it into a fraction. We are going to leave this one alone. So we need to turn into fraction. So we're going to take the x squared and we're going to bring it down. So we're going to rewrite this as the limit as x approaches infinity. And we're going to leave the sine 1 over 4x squared. And then we're going to bring this down and it turns into this. All right. Well, that actually just turned us into a 0 over 0 situation, because I still know that this is going to 0 because this is getting infinitely small. The denominator is getting infinitely large, making the fraction infinitely small. And so it's sine of 0, which is 0. And then this is a 1 over x squared in the denominator. And so a 1 over x squared in the denominator is, because I could rewrite it like that, specifically in the denominator, and that's going to be a 1 over infinity, which is approaching a 0, which now means we can do L'Hopital's rule. So we apply L'Hopital's rule. That is us still doing the limit as x approaches infinity. And then now we're going to be doing the derivative of this. And so I need to kind of have a little bit of side note on this, that this is easier to do as that. Okay, so when I do the derivative of this, I'm doing the derivative of the outside, which is cosine 1 over 4x squared, but then times the derivative of the inside. It's easier to think of it like this. So the derivative of the inside of this would be a negative 2/4 x to the negative 3. And so that's the derivative of the top. Derivative of the bottom, I don't want to write it like that. I want to leave it like this. So if I do the derivative of the bottom, I'm getting a negative 2x to the negative 3. All right. So good news is I can simplify this. I got a couple of things that I can do with these pieces. That x to the negative 3, I can cancel with the x to the negative 3. And then here I can kind of figure out what I can do with this. I have the limit as x approaches infinity, that this is a 1/2, and this is being divided by a negative 2. So if we take a negative 1/2 and divide it by a negative 2, it's the same thing as, let's cancel the negatives. It is a 1/2 being divided by a 1/2, which is a 4th. Right? So that whole thing right there can just become 1/4 times cosine of 1 over 4x squared. Now I don't have a chance to have a 0 in the denominator. I just have one value that I can plug infinity into. And so I can even manipulate a little bit more by pulling this 1/4 out and just focusing on the cosine piece. So cosine of 1 over 4x squared. All right, so now I'm ready. Go ahead and finish this problem off. That here, if I'm going to take an infinity and plug it into this, we're looking at an infinity times 4. So we're looking at a fraction of 1 over infinity, which is a 0. So it's 1/4 times cosine of 0, which cosine of 0, remember a cosine graph, cosine of 0 is 1 times 1, which makes this whole thing approaching 1/4. Oops. So if you do this at the very beginning, somehow that whole thing, if you plug in an infinity, this graph is going to level itself off to a 1/4 long term is what that means. And you can throw that into a calculator to really kind of validate and verify that that is in fact what's happening.